Hello everyone, myself Simran from Team CloudyML, and today I welcome you all to our YouTube channel. Today's video is a special video as we are going to see a SQL crash course, okay, and it will cover the basic and intermediate topics of SQL. So this video will help you if you have an urgent interview and you want to learn SQL in a very little time. So in a matter of 1 to 2 hours, you will be learning the basic and intermediate concepts of SQL along with some practice queries. Okay, so these are the contents that we are going to cover today. These are hardly 13 topics that we are going to cover. So starting from introduction to databases up till the case when statements and if else statements. So we're going to cover 13 topics. Let's begin one by one. First, we will be seeing the introduction to databases. So, what databases exactly are? Everyone here knows that SQL is a language that is used to handle databases. But do you know that what databases are? A database is a collection of related data items which are linked and structured so that the data can be accessed in a number of ways. Within a database, related data are grouped into tables, each of which consists of rows, which are also called as tuples, and columns. And this table looks like a spreadsheet which you have been seen in Excel. Okay, so database is a term used for a collection of objects where you can store related types of data. And if you see that databases are used everywhere nowadays, okay, it is used to store data, and the data is stored in a particular structure so that it can be accessed easily and using number of ways. For any purpose, you can access the data easily. It is a structured form of storing data. Okay, within a database, you store data into tables, and tables, as you know, have rows and columns. Columns can be also called as the features of the table, and rows are the values or the tuples. Okay, so database management system is a collection of programs that enables its users to access databases, manipulate the data, report and represent data. We will be seeing about Dbms in detail in the next topic. Okay, so database management system. Database management system is a software which is used to manage the database, correct? So for example, if you can have MySQL or Oracle, etc. These are very popular commercial databases which is used for different applications. So it is the function of a database. As you can see in this diagram, you have a database wherein you have stored all of your data in tables. Using Dbms, you can access this database or the data from this database for various applications, like using it in an application for the user, okay, through an API. You can access the data using a Dbms through the API, which is an application programming interface. Okay, so database is a collection of softwares which you can use to access the data from database, or also to manipulate the data or to create reports for the data. Dbms provides an interface to perform various operations like database creation, storing data in it, updating data, creating a table in the database, and a lot more. Okay, various functions can be done by using a Dbms. Okay, the interface that is provided by a Dbms can be used to perform various functions like creating a database, storing data in it, or manipulating the data, accessing the data, etc. So these are some of the characteristics of a Dbms. That is, it uses a digital repository. Okay, this is contrary to the file system that was used traditionally. Traditionally, what was done? There was a file, okay, and whatever data was present was manually recorded in that file. correct? But nowadays DBMS is used, which has its own advantages as compared to the file system. Okay, it uses a digital repository established on a server to store and manage the information, correct? It can provide a clear and logical view of the process that manipulates data. Okay, whatever information that you have stored in the database can be logically viewed whenever you want and however you want. DBMS contains automatic backup and recovery procedures. Also, it contains some asset properties which can maintain the data in a healthy state in case of failure. We will be looking at this asset properties in detail. It can reduce the complex relationship between data, which is also called as normalization. We will also look at normalization. It is used to support manipulation and processing of data, as we saw in the functions of DBMS. It is used to provide security of data. Why? Because the data which is stored with some authentication process. Okay, you need to create a localhost root with a user address and a password so that your data is stored securely. It can view the database from different viewpoints according to the requirements of the user. Okay, in whatever format you want, you can view the table. Okay, we will be seeing the queries also for this. Whatever data that you've stored in the database, you can retrieve it in different forms. Sometimes you want certain columns to be displayed or certain rows to be displayed. So using various queries, this can be done. Coming up to the asset properties. What are asset properties in DBMS is a database's contents can be accessed and possibly modified as a part of a single logical unit of work known as a transaction. So asset properties come into picture when a transaction comes into picture. What is a transaction? Basically, transaction is a procedure of operations. Okay, operations performed one after the other are called transaction. Read and write operations are used by the transaction to access data. Okay, so if you see transaction, if you have been to a bank, then you may be knowing that transaction is nothing but when you withdraw some money from your bank or if you deposit some money in somebody else's bank. So transaction is nothing but suppose there is a action A, then you perform action B, then you perform action C, then you perform action D. This entire process can be called as a transaction, wherein the transaction begins at the action A and it ends at the action D. Okay, each procedure or each step comes one after the other. So such procedure are called as a transaction. Okay, so in DBMS also you have these type of transactions. Certain attributes are followed before and after the transaction in order to preserve the consistency in a database. And these characteristics are referred to as asset properties. Okay, we need to follow some properties or some properties are maintained by the DBMS to preserve the consistency in a database. So what are these asset properties? Let's see. In the asset properties, A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. Let's see each of these terms one by one. So A, which is each transaction is all or nothing. What does this mean? As I've stated in this example, suppose there are 4 steps in a transaction. This is transaction T. Suppose in transaction T, you have A step, then the B step, then the C step, and the D step. What is the atomicity rule is that suppose while performing this transaction, suppose A step is fulfilled, B is done, but while performing the step C, some error occurs and it is not able to complete. So even if C is not complete, all of the transaction will get failed. Okay, even by a failure in one of the steps of the transaction, the entire transaction will get failed. It will only pass when all the steps are passed. Okay, so that is the meaning of the atomicity property, which is each transaction is all or nothing, which is either all or nothing. Either all steps will be performed or none of the steps will be performed. This is the atomicity property of a transaction. Next is consistency. Consistency is that data should be valid according to all defined rules. I'll explain it to you. Suppose you're making a transaction. Let's take a simple example of a bank transaction. Suppose in A's account, A has 7,000 rupees, and in B's account, B has 5,000 rupees. Okay, in this case, suppose A wants to transfer some money to B. Let's say he wants to transfer 2,000 rupees to B. Now, at state 1, which is the initial state, the total amount of money in the ecosystem is 7,000 plus 5,000, which is 12,000. Correct? Now, after sending the money from A to B, here the money will be subtracted, correct? From A's account, the money will be deducted. So this will be 5,000. But in B's account, the money will be added because B has received the money from A. So here it will be 7,000. So this is the state 2. Okay, after the transaction, the final state, this was the initial state. So in the final state, the amount will also be 12,000 because 5,000 plus 7,000 is 12,000. So in the state 1 also and in the state 2 also, the data is consistent or the data hasn't changed. So that is why this is the property of consistency, which states that the data should remain consistent after a particular transaction, or no data should be lost after a transaction. Okay, this is the rule of consistency from the ACID properties. Next is isolation. Isolation means that transactions do not affect each other. Each and every transaction is independent. Okay, it shouldn't affect each other. Suppose I retrieve or I add some data through a transaction A, and in another table I add some other data through a transaction B. So both of these transactions should be independent. They should not affect each other or the table on which the transactions are being performed. So this is the isolation property, which means the transactions do not affect each other. They are being performed isolatedly. Okay. Next is durability. Committed data should not be lost even after power failure. As we saw in the characteristics of Dbms, that the data in a Dbms is backed up, okay, and it is recovered. So durability states that even if the system is failed for some power failure, the data should not be lost. Okay, this durability is maintained by the Dbms, which is a part of the ACID properties. So these were the 4 ACID properties: atomicity, consistency, isolation, and durability. Okay, let's move ahead. These are the advantages of Dbms. These we saw mostly in the characteristics as well, which means first is the controls database redundancy. What do you mean by redundancy? Redundancy is nothing but duplication of data. Duplication of data consumes more memory, so Dbms reduces redundancy, okay, and it controls redundancy so that duplicate data is not stored. Data sharing, which means you can share your data with other users, and in a single database, more than one user can manipulate the data or can add the data. Easily maintainable. Okay, the Dbms system is very easily maintainable. Then it reduces time. Why? Because as compared to the traditional file system, it is easily maintained and it can reduce time as well. Because why it will reduce time? Because it has numerous functions and numerous queries that can help you for performing certain actions. Next is backup. That data is backed up and no data is lost. Okay, because the data is backed up on the server and server is continuously open. Okay, so that is why the data cannot be lost. And it has multiple user interfaces. You can use it through multiple user interfaces. Next is disadvantages of DBMS. The first disadvantage is that it costs hardware and software. Okay, you have to pay something for using the hardware and software. Why? Because it also provides such good services, so it also needs to be paid. Then is the size, that it stores various databases, correct? So it is of huge size. So size can be a disadvantage of DBMS. Next is the complexity. The same reason we can give for complexity, because various relations are stored in it, various tables are stored. So the DBMS can get complex and complex with increasing amount of data, and higher impact of failure. Okay, because multiple users are using the database at a single time, it can also tend to failure. Okay, so this was a general idea of DBMS, which is Database Management System. Keep in mind the ACID properties, because they are mostly used. They are used in interviews. Okay, SQL based interviews. ACID properties are an important question. So next, we will be moving at another important topic in SQL or in DBMS, which is normalization of database. So what is normalization of database? Normalization is the process of organizing the data in the database. Okay, as we saw that redundancy is reduced in database, and I had mentioned that normalization is used to minimize the redundancy from a relation or set of relations. Okay. It is used to eliminate undesirable characteristics like insertion, updation, and deletion anomalies. Normalization divides the larger tables into smaller and links them using relationships. As we saw that complexity can be increased, okay, due to presence of huge data, complexity of the database can increase. So that is why normalization can be used to simplify the data and to simplify the tables and to reduce redundancy, which means to reduce duplication of data. Normalization can be used, and we will be seeing that how it can be used. The normal form is used to reduce redundancy from the database table. Now, what is a normal form? DBMS contains around 6 normal forms, and we will be seeing these forms one by one. The first one is the first normal form. A relation will be 1NF. First normal form is represented as 1NF. If it contains an atomic value, which means it states that an attribute of a table cannot hold multiple values. It must hold only single valued attribute. First normal form disallows the multiple valued attribute, composite attribute, and their combinations. So let's understand this with an example. So suppose we have a table wherein first you have the ID, the name, and suppose the phone number. In normal life also, we have an habit of giving one or more phone numbers whenever we fill certain information in a database. Why? Because if one number is not reachable, then you can have another number also. So suppose this is some data. So according to one normal form, or the first normal form, this table is not in a normal form, or this is not normalized. Why? Because here for a single value or a single attribute phone number, two values are given. First is the number 1, second is the number 2. This is not allowed in the 1NF form. Okay, this is contrary to the rules of the 1NF form. So that is why this can't be set to be in a normal form. So that is why this is not accepted in normal form, in the first normal form. Instead, if here also a single value had only be present, then this would be accepted as the first normal form. Okay, but because it had two values for a single row or a single value or single attribute, that is why it wasn't accepted as the first normal form. Okay, let's move ahead to the second normal form. For the second normal form, the relation must be in a first normal form first. Okay, this is the first condition for a relation to be in second normal form. It must be compulsorily being in the first normal form. Next, in the second normal form, all non-key attributes are fully functionally dependent on the primary key, which means that all the non-key attributes means which are not primary keys. Okay, primary key are unique identities to the table. In this case, in this example, as we saw, the ID. Whenever you visit somewhere, you have a personal identity, correct? You have identity card, you have a name. So in the case of tables also, you have a primary key, which are the unique identity of a table. Okay, so we will be seeing about the primary key in detail, but for now, keep in mind that non-key attributes are the attributes that are not primary keys. Okay, so all the non-key attributes are fully functionally dependent on the primary key. So let's check this with an example. Let's consider a table wherein you have a teacher ID. This is a teacher ID. Then the subject, and next you have the teacher age. In this case, if you notice, then the teacher age is fully dependent on the teacher ID. Correct? Because each teacher ID is unique, but the teacher age is dependent completely on the teacher ID. So this table cannot be in a 2NF form. Why? Because teacher age is completely dependent on teacher ID. And it is a option for candidate key. What is a candidate key? Candidate key is a key where if you don't have a primary key in a table, then candidate key can be represented as a primary key. It cannot be made a primary key, but it can be represented as a primary key. In the absence of primary key, the candidate key can be represented as a primary key. So if you see that the age for each teacher is belonging to the teacher itself, correct? So that is why a teacher age can be represented as a candidate key, correct? So that is why this table is not present in the first or in the second normal form. So for this, for making it in a second normal form, it has to be decomposed like this. It has to be decomposed into two tables. First will be the teacher ID and the teacher age, and second will be the teacher ID and subject. Okay, now if you observe in these two tables, teacher ID is dependent on teacher age is dependent on teacher ID. Also, subject is also dependent on teacher ID. So this will satisfy the conditions of 2NF form. In this case, subject can also be dependent on teacher ID, can also be dependent on teacher age. So this will create a confusion or an anomaly. So this will not satisfy the 2NF form, but in this case, the non-prime attributes or the non-key attributes are dependent on the primary key. So that is why this is a 2NF form. Okay. Now let's move ahead with the third normal form. So in the third normal form, a relation that is in the first and second normal form and in which no primary key attribute is transitively dependent on the primary key, then it is in the third normal form. 3NF is used to reduce the data duplication. It is also used to achieve the data integrity. Okay, what does this transitively dependent mean? So transitively dependent means that, suppose, let's understand this with an example again. I'll be making a table. See, first let's consider the column as employee ID, then the employee name, then you have the zip code of the location at which the employee is residing. Then you have a state and then the city. If you know, then in whichever location you're staying, the city and the state combinedly make the zip code. Okay, the zip code is dependent on the state plus the city. So if you see in this case also, employee name can be dependent on employee ID, but state and city are not directly dependent on employee ID, but they are directly dependent on the zip. Correct? So here zip can be considered as a candidate key, okay, because it can uniquely identify each employee. Correct? All the non-prime attributes that are given in the table are not directly dependent on the employee ID, but the state and city are dependent on the zip. Okay? This means that they are not transitively dependent on the primary key. Okay? And we have to consider the primary. We have to consider only that tables in which no primary key attribute, no non-primary key attribute is transitively dependent on the primary key. Then it is in the third normal form. Correct? But here, the state and city are transitively dependent, which means they are dependent through, they are not dependent directly, but they are dependent through the zip. Correct? This has a transitive relation. So that is why this is not in the 3NF form. For making it in the 3NF form, it has to be decomposed into two tables. How it is to be decomposed? First, the first table will contain the employee ID, then the name, and then the zip. And the next table will first contain the zip, then the state, and then the city. Okay, so this is how the tables will be decomposed, and they are now in the third normal form. Okay, here if you see, the name is directly dependent on employee ID, zip is directly dependent on employee ID, but here also you can see that state is directly dependent on zip, city is also directly dependent on zip. In the table 2, the zip is the primary key, and here the employee ID is the primary key. So all the non-primary key attributes are directly dependent on primary key. They are not transitively dependent. Transitively dependent means they are not indirectly dependent. They are directly dependent. So this can be accepted as a 3NF. Let's move ahead with the Bcnf, which is the Boy's Code normal form. It is the advanced version of the 3NF, and a table is in a Bcnf if every functional dependency x tends to y, where x is the super key of the table. Okay, here this is a representation for dependency, which is x is dependent on y or y is dependent on x, where x is the super key of the table. Let's understand this again with the example. Here also we will be seeing employee table only, but the columns will be some different columns. So let's see. First, let's consider the employee ID. Okay. Just a second. Then you have the country. Then you have the department, which is the employee department. Then the department type. And finally, you have the employee department number. Department number. So in this case also, if you see, department type directly dependent on the department number also directly dependent on the department. So in this case also, if you see that department can also act as a primary key, employee ID can also act in a primary key as a primary key. So but department is not directly dependent on employee ID. Why? Because each department can be different for each employee ID, correct? And various values of department can also be present. So that is why this table, a single table, is broken down into 3 tables. Okay, because the what we say, the employee ID, various employees can be present in a single department, or a single department can be assigned to various employees, or it can be vice versa also. A single employee can be present in various departments also. Okay, so that is why your department and employee ID, the relation cannot be just given in a single form. So that is why it is the table is divided into 3 forms. First, you have the employee ID and the country. This will be the first table. Then the second table will be of department, the department type, third will be the department number. Okay, this is the table 1, the table 2, and the third table will be of employee ID and department. Okay, this will be the table 3, which will consider the information for each employee to which department that employee belongs. So this will be the Bcnf form of the given table. Let's move ahead to the 4NF form. A 4NF form says that a relation will be in 4NF if it is in a Bcnf, which is a Boyce Codd normal form, and has no multi-value dependency. Okay, we will see that what a multi-value dependency means. And also, for a dependency, A tends to B if for a single value of A, multiple values of B exist, then the relation will be a multi-value dependency. This is the definition for a multi-value dependency, which means if A is a single value but B has multiple values, then this is a multi-value dependency. So, in 4NF, multi-value dependency cannot be possible. Let's see an example for this. Okay, so suppose we have a student ID, course, and hobby. Okay, so here if you see that, suppose a student, if you observe, then student can have various courses. A single student, suppose this student has computer. Again, the first student has a course maths, and he has different hobbies also. Suppose he likes to dance, dancing, singing. So, in this case, multiple values are present on a single value, or are dependent on a single value. Okay, on the primary key 1, various values are dependent. Correct? So, this has multiple valued dependency. So, this cannot be a 4NF form. Correct? So, for 4NF form, you have the condition that no multiple value dependencies can be present. So for decomposing this in the normalized form, you need to create 2 tables for decomposition. First, we'll have the ID and the course. Second, we'll have the ID and the hobby. Okay, so that is why now only a single course, or only the course values will be dependent on the ID. Here only the hobby values will be dependent on the ID. So this will be in the 4NF form. Let's move ahead with the 5NF form. So now a relation is in 5NF if it is in 4NF and not contains any join dependency, and joining should be lossless. 5NF is satisfied when all the tables are broken into as many tables as possible in order to avoid redundancy. Okay, so what is an example of this? That suppose you have a table which has subject, lecturer, and semester. All the 3 columns are independent of each other, and they can be broken down into as many tables as possible to avoid redundancy, then that table will be in the 5NF form. Okay, so this was the example of 5NF form where the table can be broken down into as many tables as possible. Okay, and it does not contains any join dependency. So we saw the six forms of normalized table, which is the first normal form, second normal form, 3NF, third normal form, Bcnf, 4NF, and 5NF. Now let's move ahead to the SQL topic, okay, for which we are studying this video, the SQL crash course, which is the SQL. SQL, as we all know, stands for Structured Query Language. It is used for storing and managing data in relational database management system. What is a relational database management system? Where the data is stored in the form of relations. As you know that in a database, related data items are stored. What do you mean by related? Suppose a table storing student values and a table storing teacher's value. Then how are these two tables related? Teachers teach students. So this is the relation between them, correct? So SQL is used for storing and managing relational databases. It is a standard language for relational database system. It enables a user to create, read, update, and delete relational databases and tables. Okay? All the RDBMS like MySQL, Informix, Oracle, MS Access, and SQL Server use the SQL as their standard database language. Okay, so all of these softwares that and SQL Server that are mentioned use SQL as their standard database language. So given below are some of the SQL data types. You can go through them one by one. First, you have the numeric, the date time, character string, Unicode character string, binary, and miscellaneous. We will be looking into these data types when we start writing the queries and when we start creating the tables. So SQL, which is the structured query language, contains 5 types of commands. Okay. So the first is the DDL, which is the data definition language. From the name only you can understand that it is used to define something. And what we will be defining? We will be simply defining the tables. So this language, the commands in this particular language are used to define the structure of the table. Okay. So the commands in this are create, drop, alter, truncate. We will be looking into these commands one by one soon. Then we have the DML, which is the data manipulation language. What does manipulation means? Manipulation is changing the data in the table. So how will you manipulate the data? We have the insert command, the update, and the delete command for this. Next, we have the DCL, which is the data control language, in which you will be having the grant and revoke commands, which are used to give some authentic or a permission to a particular user to perform certain actions on your database. Next, we have the TCL, which is the transaction control language. We have already seen that what a transaction means, and these are certain commands that are used to handle transactions. First is the commit, rollback, and save point. And finally, you have the DQL, which is the data query language. And what does the data query language does? It is used to retrieve information from the Dbms or from the table. Once you have created the table, you have inserted data into it, then the next will be to retrieve the data for some purpose. So for this, you will be using the select command. Okay, and in this particular crash course, in this video, in the basic and intermediate part, we will be looking at the DDL, the DML, and the DQL part in this video. So if you want to learn about DCL and TCL, we will be covering it in the advanced SQL crash course. Okay. So for this particular tutorial or for this crash course, we are going to use the Mysql Workbench because it has its own benefits. Okay. So I've provided the link to download the software. This crash course is completely performed in Mysql Workbench. So properly select your OS type and download the Workbench. I've also given a reference link if you find some difficulties in downloading the software. Okay, the version that I've used is 8.0.27, but you can use any other suitable version for your OS. So follow this YouTube video to download the Mysql Workbench. First, to create the tables, to make the structure of the data, to apply certain constraints on the table, etc. So let's see the first command from the data definition language, which is the create command. The create command is simply used to create a database or a table. This is the syntax for the same. Syntax, if you have done programming before, syntax is nothing but a procedure or certain steps or a certain outline that has to be followed for performing a certain operation. Okay. So here is the syntax, which is create table, table name, whatever table name you want to give. Then you need to specify the column name, then the column type, and the constraints. Okay, for constraints, we are having a different topic. Okay, if you had visited the index, the constraints have a different topic. We will be covering the constraints in detail. But for now, we will be not looking much into constraints. We will be only focusing on the column name and column type. Create a table cars having columns like serial number, model name, company name, launch year, type, passengers, and mileage. Okay, so I'll show you how to do it on the MySQL Workbench. This is the interface of the MySQL Workbench. When you enter, you will be having such a page. What you can do is you can click on this plus and you can create a new connection. Type in your connection name over here and you can click on OK. Once you do that, new connection will be created. So I have created a connection for myself, which is this SQL crash course. When you open the connection, you will see such a interface over here. Okay, so what you will be doing for this interface, here you can write all your queries and you can explore this interface as much as you can. Okay, the more you explore, the more you will know. Here are all the databases. If you see, these are the list of databases. You can use any of the database from this, but for now we will be creating a new database. Let's see how. As you saw, that create command is used to create a database or a table. So create database. Let's give the name as SCC1, which is SQL crash course. Use SCC. When you type the command use SCC, then whatever further actions you are doing on the database SCC1. That is why we use the command use. What you are going to do for running this command, I'll show you. Suppose you want to run this first command, you need to select it and press on this thunder symbol. Okay, only the first thunder symbol. And if you want to know your result, you can see in this panel below. Here you can see that the action output create database SCC1 and you can see the message 1 row is affected, which means the action has been performed. Here you can see a green tick. Next, for using the database, select this again, press on this thunder. So you see a green arrow is present and you can see that 0 rows affected, use SCC1. Okay. Now we are into the database SCC1. How to create the table now? We need to create the table which has the name cars. So write the command create table cars. Okay. Now we will be putting in the column names. The first column name is serial number. And while putting the column names, we also need to specify the data type. So the column name or the data type for serial number will be int. Int is the integer data type. Okay, it will have numbers like 1, 2, 3, 4 up till infinity. So for serial number, we will be giving the data type as int. Next column we have given is model name. Okay, so this is model underscore name. The data type that we will be using for model underscore name is varchar. Varchar is that it can be a combination of various characters and it can also have digits into it. Okay, so that is why the name is varchar, and let's give the size as 20. Okay, 20 characters can be present in the name. Next column is company name. So wherever you have some characters, you will be giving the data type as varchar. You can also increase or decrease the size of the data type. Then you have the launch year. So for launch year, we will be using the int data type. Why? Because it is only a year, like 2001, 2002, 2003. If it had been entire date, then we had to use the date data type. After launch year, you have the type. Type as in if it is a SUV, it is a hatchback or whatever. So we will be using varchar in this case. Maybe I'll increase the size. Okay, next you have passengers, which is the number of passengers. Passengers, we shall keep it as int because we have a number of passengers, right? So there and there only we can understand that it will be an integer. And then the mileage. Now mileage cannot be a perfect number. Okay, it will be in decimals. So for that we are using float. Float means decimal point numbers. And an important syntax in SQL is that you need to put a semicolon after each line of code. Okay, after particular proper line of code, it marks the end of a single query. Okay, so run this entire thing and click on the thunder. So you see the table has been created. Now let's move ahead with the next command, which is the alter command. An alter command is used to modify an existing database table. Okay, it is used to change the structure of the existing database table. So what is the syntax for this? Alter object type. Object type means it can be a table, it can be a view, then the object name, and then the parameters. So what we will be doing is alter the cars table to add a column rate. Rate means the price of the car. So let's see how to do that. You'll simply write alter table. Table is the object type. Then the table name, which is cars, and you want to add a column, correct? So you will be writing add column rate. You also need to write the data type for rate. So let's write this as int. You don't need to specify your columns. There it is. So what you'll do, alter table, cars, add rate, int. Int is the data type for the column rate. So select this and run. The altered table has been added. Okay, the table, the row, the new column has been added. Let's move ahead to the drop command. A drop command is used to delete objects such as a table, or index, or a view. So the syntax is simply drop, object type, and object name. What drop will do is it will delete the entire table along with the data present in it. Okay, so drop the column rate and then the entire table. So let's see how to drop the column first. Drop column rate. So for drop column rate, we will be using the alter command. Okay, alter table cars, drop column rate. Run. So the column has been dropped. How to drop the table? You can simply use the drop now. You don't have to use the alter. So drop table It is a table, right? Drop table cars. Now select this and run. So you see green tick has been appeared, which means the table has been dropped. Next, after seeing the drop command, let's see the truncate command. Truncate is similar to drop, but the truncate statement is used to quickly remove all the records from a table. Okay, what drop will do is it will delete the table completely. Okay, it will not keep the structure as well as it will not keep the data. But what truncate will do, it will keep the structure, but it will delete all the records from it. We will be seeing this truncate command in a few while, because we don't have any data in the table. So for deleting the data, first we need to have the data in the table. Okay. So next we will be looking at the data manipulation language, wherein we are going to insert some data into the table, we're going to update some data. So let's see how to do it. The first is the insert command. It is used to insert some records in a database. This is the syntax which is given, that is insert into table name, the column names, and then the values. Here you can give the records. So insert some suitable records in the table. First, for inserting the records, we first need to create the table because we had dropped the table, correct? So let's recreate the table. Also add this column rate. Okay, so the table has been created. These are the commands for adding some data into the table. I'll show it to you. I've taken some random values. Okay, you can use any of your values. See, this is the command insert into cars. Okay, this is the table name cars. Values, you can directly give the values, no need to mention the column names. I will show that when you have to mention the column names. When you want to skip a certain value, okay, suppose I don't want to add the model name, then leaving model name, all the column names should be given over here, or else it will give an error. Okay, so in that case you need to specify the column names, but now you will have to give the records in the order in which the column names are present in the table. Okay, the order should be maintained. The order, if you put Maruti Suzuki Swift in the place of 1, it will give you an error because Maruti Suzuki Swift is not a int. It is a varchar, correct? It is a string. It will give you an error. You need to pass the values in the form of the columns that are present in the table. So these are some of the values that I've given. This is the rate, this is the mileage, the passengers, type, hatchback, year. Okay. So what you can do is you can select all of these at once and run. What this will do, it will insert the data into the table. There's some error, I guess. Let's check. No worries, we'll see it afterwards. Okay, so the data has been inserted into the table. Now let's look at the update command. Update command is used to change or update the current or existing data. Okay, or from the name only you can see that it can update the current or existing data. This is the syntax for the same. Update table name, set column name is equals to value. Value is the new value that you want to give. Where condition. Okay, let's see it with an example. Update the mileage of the Hyundai Accent car. What do you want to do? You want to update the mileage of the Hyundai Accent car. Let's see where the Hyundai Accent is. This is the Hyundai Accent car. The mileage now is 72.7. Let's see how to update it. Yes, what you will do, update the table name, which is cars, set column name, you want to update mileage, correct? So update mileage, set mileage is equals to, let's give a new value as 80, where how it will understand that which value to update by using the where. You can give where model underscore name is equals to, the model name is Hyundai Accent. Okay. Now select this and run. As you see, the query has been performed and one row has affected, correct? So we have updated the value of mileage to 80 for the Hyundai Accent car. In the place of model name, you can also use the serial number because it is easy, okay? Instead of typing the entire name, you can simply use the serial number. Next, you have the delete command. Delete command is used to delete some or all of the records from the existing table. Okay, we can use the delete command to delete a single record, 2 records, 3 records, or any number of records that we want based on a certain condition. This is the syntax that delete from table name where condition. Okay, so now let's delete the last record from the table. The last record in our table is having the serial number 12. So let's see how to delete it. Delete from table. Delete from table name, which is the cars. What you want to delete? The last record. So you will say where serial number is equals to 12. Select this, run. So you see the table, the row has been deleted. Okay. Next topic in the crash course is the data query language. So data query language, as we saw, is used to retrieve the data from the table. So we are going to look at the select command here. This command retrieves the data from the table. Simply, you need to select the column names from table name. Display the records from cars table. So how to do it? What you will do, select column names. Okay. If you want to specify 2 columns, you can give the names of 2 columns. But if you want all the columns, you need to give star. Select star from cars. Let's see what do you get. So as you can see, you've extracted the entire table and you can observe that in this table we have only 11 rows. Why? Because we had deleted the row number 12, okay, having the serial number 12. So that is not present in the table. So from this you can check whatever changes you have made in the table, you can verify by using the select command. Okay, select is used to retrieve the table records. Now in this we had selected the entire records. But what if we want to select only some part of the table? Suppose we want only 3 columns, which are the serial number, the model name, and the rate. So what you will do is, you will specify the names of the columns that you want to extract. Okay, so I am specifying serial number, model name, and rate from the table name, which is cars. Now select and run. You will observe that you have got 3 columns, serial number, model name, and rate. So many different other functions can also be used with the select command. We will look into those functions as we move ahead in the crash course. Okay, so let's move ahead to the next topic, which is table constraints. Now, table constraints in SQL is a very important topic. Why? Because it allows us to ensure that what type of data you want to insert in your table. Okay, table constraints are used to put some restrictions to the data that you insert in your table. It is used while you create the table. Okay, table constraints are used with the create table command. I had mentioned it before in the syntax of create table. I'll show you. Okay, in the data definition language, we had seen the create command. So in that create command, I had shown you the syntax. So here you can see we have create table, table name, column type, and constraints as well. So these constraints are the same as table constraints that we're going to see over here. Okay. So now let's move ahead with the topic of table constraints. In SQL, we have 6 table constraints, which are the not null constraint, check constraint, unique constraint, primary key constraint, foreign key constraint, and default constraint. Okay. So let's see the table constraints by creating the table. So what first we will do is, first let's draw our table cars so that we can again create it with constraints. So select this to draw. Okay. And this was the query of create tables. So we will put constraints in the same query only. Okay. So I'll just take it down. This is the create table cars. In this, first let's look at the not null constraint. So this constraint tells us that we cannot store a null value in a column. Null value is an empty value. That is, if a column is specified as not null, then we will not be able to store null value in this particular column anymore. Okay, what it means that we cannot store any empty value in that table. Okay, no null value is allowed. So let's give the constraint of not null over here, not null. Okay, this is the way you specify the constraint. Okay, we had seen the syntax. First the column name, the column type, and the constraint. Let's move ahead with the next constraint, which is the unique constraint. This constraint, when specified with a column, tells all the values in the columns must be unique. Okay, that means you cannot have duplicate values in that column if you specify the constraint as unique. All the values should be unique. So let's give the unique constraint to the model name. So this is unique. Okay. Next, the constraint is the primary key constraint. So a primary key is a field which can uniquely identify each row in a table. Okay, so primary key is an important topic in SQL, which is like we all have an identity. Our identity is a name. So in the same way, a table also has an identity which is called as the primary key. The primary key represents the entire table. Okay, it is uniquely identified by each row in a table. So in our table, the serial number can be called as the primary key because it is unique. So what you will do, you can specify the constraint primary key over here. Okay? And primary key is a combination of not null and unique constraint. Okay, so if you give the constraint as primary key, then automatically not null and unique constraints are also applied. Next is the foreign key. Foreign key we will see by using a new table. Okay, so for that we are going to use another table because foreign key is a field which can uniquely identify a row in another table. I'll explain it to you with an example once we finish with the other constraints. Next is the check constraint. This constraint helps to validate the values of a column to meet a particular condition. Okay, so suppose you want to specify that in a particular column or in a particular table, you want only those age values that are greater than 18. So you will give the check constraint as age is greater than 18. So that when you insert some data, it will automatically check whether your age is greater than 18, and it will only allow those values to be inserted which are greater than 18. Yes, so in our table, let's see that we allow only the year which is greater than suppose 2000. So check launch underscore year is greater than 2000. Okay. So we have applied the check constraint here. Next, we have the default constraint. So this constraint specifies a default value for the column when no value is specified by the user. What this means is, suppose we want to have a default value like country. So whenever we insert data, if we miss out the country value, then the table will automatically fill the country value as India. So while creating in the default constraint, you have to set the country value as India so that whenever the value is missed by the user, the table will automatically fill the value India into that column. Okay, so it is a default value for the column when no value is specified by the user. So these were the table constraints. Let's run this query and see. I suppose the table is not dropped. First, let's drop the table. Use the database. No worries, we will change the name of the table. Let's make it as cars1. Okay, now you can create this table. So the table has been created with the constraints that we had given. So now let's see the foreign key constraint that I had kept on hold. So for a foreign key, we will be creating another table which is the buyers table. So this is the query for creating the buyers table, and I'll explain foreign key constraint using the buyers table. So create table buyer. In this we have the buyer ID, int, which is the column type. It is a primary key, which means ID is the primary key for the buyers table. Then we have the buyer name, which is varchar. It is not null and also unique. I'll take it down so that you can see it properly. Then you have the model number, that which model number the buyer has bought. Then C, we have the age column in that int, which is the column type. And here we have used the check constraint, wherein it will check whether the age is greater than 18 or not. Similarly, you have the nationality of the buyer, and the default nationality we have set as Indian. Okay, you can see the use of the default constraint over here. We have set the default constraint as Indian, and the foreign key. Now this is the foreign key constraint. Foreign key model number. Model number, you can see this is the model number. References cars serial number. What this means is that the model number in this table is the foreign key for the serial number in the cars table, okay, in the cars1 table. This is the difference between a primary key and the foreign key. A foreign key is the primary key for some other table. Okay, in this case, serial number is the primary key in cars1 table. But in our case, the model number is the foreign key for the cars table. Okay. So this is the use of foreign key. It can be used to join two tables based on a single column. So references cars, let's make it cars1 serial number. Okay, so what this model name is same as the serial number column in the cars1 table. So select this command to run the query. Okay, and the table has been created. So these were the various constraints, the table constraints. So next, we are going to see the where operator, comparison operators, and logical operators. So the SQL where clause is used to specify a condition while fetching the data from a single table or by joining with multiple tables. So what this where operator does is, suppose we want to retrieve only particular rows from a table, then what we are going to do? We will specify the where condition. Okay? Where condition is used to extract only particular rows or particular columns of a table. And these are various comparison operators. As you see, equal, not, equal or not equal to, greater than, less than. Okay, these are the normal comparison operators that we use in mathematics. And further, we have the logical operators. We have the all operator. It returns true if all of the subquery values make the condition. Then we have the AND operator. It returns true if all conditions separated by AND is true. Okay, and all the other operators as well. We will look at some of the operators using an example. So these are some of the examples. Let's solve these examples so that you understand the topic better. So the question is, return the records of cars of company Maruti Suzuki. So you want to return the records. Records means all the records for the cars of which company? Of the Maruti Suzuki company. So let's perform this query. But before that, you have to insert some records in the cars one table. Correct? Because we just created that table, right? So let's insert some records in it. So all this has to be made cars one. So select this and run. Column count. Okay, we have to insert another column also in it because this rate column we have to insert. Make it cars one. Select run. So the rate column has been inserted. So you see the queries have been performed and the data has been inserted into the table. Now what we want to do, we want the records for the cars for which the company name is Maruti Suzuki. So what you will do, select. Select is used for retrieving the data, correct? So select star. Why star? Because we haven't, in the question, they haven't specified that what columns you want. Okay, you want all the columns, but for only the company Maruti Suzuki. So you will select star from cars 1, where company name is equals to, you will write Maruti Suzuki. Okay, now run this. And you see, you've got only those records for which the company name is Maruti Suzuki. You have 3 records of the type. Okay, so this is the way you use the where command. Next question is, retrieve the car names having mileage greater than 75. Now in this you are using the greater than operator who have the mileage greater than 75. So what you will do, and you just want the car names. So you will just select the model name. So select model underscore name from cars1, where what you want, mileage greater than 75. Correct? So this will only retrieve the cars for which mileage is greater than 75. So these are the cars. Okay. You have retrieved only some of the cars. Next, get the car names having company name Hyundai and mileage greater than 75. Okay, now you have 2 conditions. So how to join 2 conditions? You use the AND operator to join 2 conditions. Okay, so let's see how to join the 2 conditions. What you will do, select what they have asked to retrieve, car names. So similarly, you will just retrieve the model name from cars 1, where company name equal to Hyundai, and so this is the AND operator, and mileage is greater than 75. Now let's see what do we get. So you see there is only one car which satisfies both the conditions. Let's also check the company name and mileage so that you can verify the answer. Okay. So now we will be retrieving three columns: model name, company name, and mileage. So you see the company name is Hyundai and the mileage is 80. 80 which is greater than 75. Next question is show the car names of the company Renault or Datsun. So now you have the OR operator coming into the picture. So what you will do, retrieve the car names from cars one where company underscore name is equals to Renault or company name equal to Datsun. It will retrieve either of the values, okay? It will retrieve the value even if the company name is Renault, or it will retrieve the value even if the company name is Datsun. So select this. Let's also retrieve the company name so that you can see whether the answer is correct or not. So you see three values have been retrieved. You can see the company names are Renault, Datsun, Renault. So let's move ahead with the next query. Display car names launched in the years between 2012 and 2016. So now in this case we will be using the between operator. Okay, I'll show you how to use it. So what you will do, select model underscore name, comma launch year from cars one, where what you want launch year between 2012 and 2016. So here as you can see we have also used the AND operator along with the between operator. So select and run. So you see the years 2014, 2016, 2014, 2015. So we've got the correct output, right? So this was the where command, the comparison operators and the logical operators. You can make your own queries, okay, using all these operators. You can try all of these operators in not or exist like, so that like you practice all the operators. You can make your own questions and write your own queries using your own data. Let's move ahead with the group by, having, limit, and order by. So the group by is a statement which groups rows that have the same values into summary rows. See, in this example, we have three columns. Let me zoom in. So we have three columns. First is the title, then the genre, and the price. So what group by will do is, if you can see, then genre has three types: adventure, fantasy, and romance. So what it will do is it will aggregate the data. It will group the data based on the genre. You can specify by a query, while writing the query, you can specify that on what column you want the group to be made. So if you specify the column as genre, then it will group by based on genre. So you see it has grouped by based on adventure, fantasy, and romance, and it has calculated the average price. Okay. If you see for adventure, you have two values, 11.9, 9.99. So it has calculated the average. Similar to average, you can also apply more aggregate functions like sum, max, min, count, etc. We will look at those in details. So this is the syntax for group by, which is select column names from table name, where condition, group by column names. So these are some of the aggregation functions of group by, which are count, sum, average, max, and min. Let's solve some questions related to this. So find the number of cars of each type. find the number of cars of each type. So if you see in our table, we have a column called as type. In that we have SUV, we have hatchback C. This is the column type. Sedan, MPV. So we want to know the count of cars which are present in each car type. So what we will do, select count of cars, which means count of model name as let's give a column name to this count as count of cars. Specify the table name cars1, where I don't think there's a requirement of where over here, so simply we will group by based on type. Let's print the type as well. Select this, run. So you see, crossover type has 2 cars, hatchback type has 4 cars, MPV has 2 cars, sedan has 2 cars, and SUV has 2 cars. So total we have 5 types of cars, and these are the number of cars of each type. So this is the way you use the group by. Let's solve the next question. Display the average mileage of each type of car. So what you want to display? Average mileage of each type of car. So let's see how to do that. First, let's select type. Then what we will do? Average. We want the average of mileage column. So mileage as average mileage from cars1, where, group by type. Now select and run. So you see, you've got the average mileage for each type of car. Next, calculate total car mileage for each company. Now you want total car mileage. Total means you will calculate the sum of mileage for each company. Let's do it. So select, again, you want company name, right? And you have to calculate the sum of mileage as total mileage from cars1, and you will group by based on the company name, company underscore name. So now select this and run. So you see the total mileage for each company is given. Okay, it has simply added up all the mileage values and it has printed that according to the company name. Now let's move ahead with the next question. Display the oldest model launched for every company. Oldest model launched, which means you will consider the minimum of the launch years. The smallest launch year will be the oldest model. So what you will do, you will group by based on the company name, and by group by you will apply the minimum aggregate function. So select company name, comma, minimum launch year from cars1, group by company underscore name. Okay, so you see, this is the minimum launch year. I guess we have to display the oldest model launched for every company. You also want to display the model name, not only the year. So what we will do, see, we have the company name, we want the model name. Here we are going to use now the where function, where command. What we will do, where launch underscore year in select min launch year from cars 1 group by group by group by is also not required. This may be fine. I'll explain the query to you. First, let's check whether it is correct or not. Okay, so this is the correct query. I've made some changes into it. Okay, so what we are doing is we are retrieving the company name, the model name from the cars1 table, but for which table, for which columns, for which only the launch year is present in select minimum launch year from cars1 group by company name. What this will do is it will extract the minimum launch year for each company. Then it will compare these launch years with the current launch year and it will check whether the launch year is minimum or not. If it is minimum, then it will retrieve the model name. Okay. So when you run this, you get this output. So you can see that Hyundai Grand i10 is the oldest model for the Hyundai company. Similarly, Maruti Suzuki S-Cross is the oldest model for Maruti Suzuki and so on. So next question, display the latest model launched for every company. So it is just similar, but the only difference is the aggregate function. For each company, the latest model will be having the maximum launch year. Okay. So what you will do, you will just change this max function and then select and run. So these are the names of the companies or the models which are the latest models for each company. Now let's move ahead. We are going to look at the having and the order by statement. The where clause cannot be used to filter the grouped rows based on a condition. For that, we have the having clause. Okay, so if you remember, the where clause is used to filter the records. But if we want to filter the records which are grouped using group by, then we use the having clause. Okay, and the order by clause is used to order by the rows, the retrieved rows based on some column. This is the syntax for the same. We will understand this with the help of an example. So, display the count of car models for each company having more than one model in ascending order of count. So first, let's display count of car models for each company. So how you will do that? Select company underscore name, comma count aggregate function, and the count should be of model names from cars1 group by company name, correct? And what we have asked to do is only we have to retrieve those data for which the count of cars is greater than 1. See, having more than one model. So here you will use the having clause, having count of model name greater than 1. So it will retrieve only those company or the count of model names which are greater than 1 ahead in ascending order of count. So similarly, you want to order by the data based on the count of model name and ascending order. So you don't need to mention anything. So select this and run. So you see only the count which is greater than 1 is retrieved. See 2, 3, 3. All these 3 are greater than 1 and the company name and the corresponding count of models is retrieved. And it is also ordered by the count of model name in the ascending order, correct? Let's see the next question. Retrieve the car records in decreasing order of mileage. Now you have to use the decreasing order of mileage. So what you will do, select star from cars1, order by mileage, and now you have to specify the decreasing keyword. Okay, so now it will give the car having the highest mileage first, and it will order it by in the decreasing order. So you see 50 is the smallest mileage, so it is displayed at the end. So this was the having an order by clauses of SQL. Next is the limit clause. The limit clause is used to set an upper limit on the number of records returned. So retrieve the top 3 records based on rate. Now what you want to retrieve the top 3 records, which means the cards having the highest 3 rates. So select star from cards. First you need to order it by rate, that too in the descending order. Why? Because when you have it in the descending order, it will display the highest rate in the first row. Correct? So order rate and then limit 3, which means it will only retrieve the top 3 records. So run cars 1. So you see you have the top 3 records 9 lakh, 8 lakh 30,000 and 8 lakh. Let's move ahead with the next topic, which is the joins in SQL. Join statement in SQL is used to combine data or rows from 2 or more tables based on a common field between them. Okay, so if you want to retrieve the data which is from the 2 tables, then you have to use the joins. And join is only applied when you have a common column between the 2. Okay, for that we had used the foreign key. So the foreign key is a linking between 2 tables. So that is why a foreign key is mandatory if you want to use the data from the 2 tables. So these are 4 types of join in SQL. First is the inner join. Suppose there are 2 tables, the left table and the right table. So the inner join will only retrieve the common data between the 2. So you see this yellow part is the common records between the 2 tables. So the inner join will only retrieve the common records. Next is the full join. Full join will retrieve all the record from left table, all the record from right table, and also the common records from both the tables. Next is the left join. What left join will do is, it will retrieve all the records from the left table, but only the common records between the 2 tables. Similarly, right join will retrieve all the data from the right table, but only common records between both the tables. So these were the 4 types. Let's see an example. Display the model number, model name, and buyer name for common models between the 2 tables. So first let's insert some data into the buyers table that we had created. So this is some data. In this we have the buyer ID, the buyer name, the model number, and the age. So run this. So data has been inserted. What do you want to retrieve? We want the model number, the model name, and the buyer name for common models between the 2 tables. So between the 2 tables, we have a common column, which is the model number. So what you will do is select model number, comma, model name, comma, name of the buyer from. This from is very important. Just pay attention how I'm joining the 2 tables. So from the first table, the name of the first table is cars 1, and the other table is buyer, where now you will specify the common columns. So the common columns are serial number and model number. So where cars.serial number is equals to buyer dot model underscore number. So this is the example of inner join. Select and run. So you see, these are the records that we have retrieved. It has the model number, model name, and name of the customer who has purchased the particular car. Okay, so these were joins. You can try all of these joins one by one. Next, you have the nested queries. we have already used nested queries in the previous examples. So a nested query is a query that has another query embedded within it. The embedded query is called as a subquery. Not only two, but 3, 4, 5, as many as queries you want, you can embed that many queries in a single query. So you see, select star from table name 1. So this is the first table where column names is equals to. So this is a part of the outer query and this is an inner query. Select column names from table name 2. So this is the second table. The nested queries can be applied on a single table, on 2 tables, 3 tables, 4 tables, as many as tables as you want. So display the model number, model name of the cars that have been bought by the buyers. So which cars will be bought by the buyers? For that cars only for which the model number is same as the serial number in the cars table. So see what you will do. Select, you want the model number, right? Model number and model name of the cars that have been bought by the buyers. So you will retrieve the serial number, comma, model underscore name from cars 1, where the serial number in, now what you will put in select model underscore number from buyer. So it will compare the model number and the serial number, and it will only retrieve those which are present in the cars table. Okay, so you see that 10 is present in the buyers table also and in the cars table also. So it has retrieved the model name. 3 is also present in both the tables. 5, 8 and 1 all are present in both tables. That is why it has retrieved that data. Let's move ahead. This is the case when statements and the if else statements, which is the last topic for this video. So let's understand the case when statement. The case when statement in SQL returns a value on a specified condition. We can use a case when statement in select queries along with where, order by, and a group by clause. Okay, so this is a simple flowchart. Suppose we have numerous conditions, and based on those conditions, we want to perform certain action. So what we can do is we can specify various cases and the action that you want to perform based on the case. So suppose this is the first case, which is the case 1. If this condition matches, then the statement 1 is performed and the loop breaks. But if it does not match, then it will check the case 2. If the case 2 matches, then it will perform statement 2 and break. But if it does not match, it will continue for n cases. Any number of cases can be used. But if none of the n cases match, then you can give a default case and the default statement will execute. Okay, and the control will go to the next statement. This is a simple flowchart. See, this is the syntax. Select case, expression. Expression is nothing but the column where you want to apply the case. When keyword is used, then the first expression you can pass, then result 1. Result 1 is the action that you want to perform. Similarly, it will go up till else. Else will give the default condition. So result is the default action that you want to perform. And don't forget to use the end in the last. Okay, let's solve a question on this. Retrieve the model name and corresponding launch year in the form after 2015 for launch years greater than 2015, between 2010 and 2015 for launch years between 2010 and 2015, before 2015 for the rest. Okay, so you want to display this string for the particular launch years. So I'll show you how you have to do it. What you will do is select what you want, the model name and corresponding launch year. So select model underscore name, comma. Now you will apply the case. Case launch year when, now this is the first case where launch year is greater than 2015. Then what you will display? You will display the string after 2015. Next, the next case where launch year is between 2010 and 2015. So it is greater than 2010 and less than 2015. Then what you will display? Between 2010 and 2015. And for all the other records, you will display before 2015. Sorry, before 2010. This first condition, okay, before 2010. Then end as, we will give a column name launch year. And don't forget to give the table name cars1. So let's see the output. Okay, so you see before 2020, before 2010. I guess there's some mistake. Let's check it out. Just a second, remove this case. And now let's see. Okay, so you have got this output. See, before 2010, after 2015, between 2010 and 2015, etc. Okay, so what it has done, it has just removed the exact launch year and it has put an estimate, okay, if it is after 2015 or if it is before 2010. Okay, so similarly, case when statements can be used in insert statements also, in order by also, using where statement also. So next we have the if statement. The if statement is used for stored programs and it implements a basic conditional construct. So syntax is this: if condition, then result 1, else result 2. So what it will do is it will check this condition. If the condition is satisfied, then it will perform result 1. Or if the condition is not satisfied, then it will perform result 2. Let's understand this with the help of an example. Retrieve the model name and the corresponding rate as high for rate above 5 lakh and low for others. So you want to retrieve the model name. So select model underscore name, and next what you want to select? The rate, corresponding rate as high, okay, for rate above 5,000 and low for the others. So what you will do over here is simply print the rate, and if rate is greater than 5 lakh, this is 5 lakh, then you will print high, or else you will print low from cars1. Run this. So you see, the rate is 3,000, so it has printed low. 4,000 printed low, but this is greater than 5 lakh, so it is printed high. 6 lakh high. 2 lakh 50,000 low. Okay, so similarly you can use this if condition in various other applications, in also in other tables also. Okay, so we have come to an end of this crash course. In this crash course, we covered the basic and intermediate topics of SQL. We have covered 13 topics overall, starting from introduction to databases, data management system, normalization, SQL, DDL, DML, DQL, then the table constraints, then where, comparison operators, logical operators, group by, having, limit, order by, and the joins, then the nested queries, case when statements, and if else statements. So you can practice more and more questions based on these all topics. Okay, and do ask your queries. If you have any question related to any topic from this crash course, you can definitely ask your queries in the comment section. We are always ready to solve your queries. Okay, so you can also practice the questions that are performed in this crash course, or else you can use any other table and any other queries to practice yourself. So if you like this video, do share it with your friends and subscribe to our channel for more such courses. Thank you.